Hi, boys and girls. I've had a couple questions on how to figure out the area of some of these bigger rooms since they involve multiplication problems that we really haven't talked about. So I wanted to go over that real quick with you. I want to start with one that would be easy for us to look at, and we're just going to look. This is my example page. Yours does not have to look like this. I want to look at this guard room. Okay, and I want to figure out the area of this guard room. Remember how I told you to draw your lines very carefully so that you could go back and figure out the area? So now we're going to figure out this area. So let's see, we have 1, 2, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5. So I have 5 rows, 4, 5, with 6 in each row. Okay. Oops. So, since 6 times 5 equals 30, the area equals 30 square units. And I could always go back and check that. Let's see, I've got one. Well, you know, it'd be easier to go this way. If there's 1, 2, 3, 4, 5, I've got 5, 10, 15, 20, 25, 30. 30 square units. Each one of these is a unit and it's a square. Okay. But what if I'm doing the ballroom? All right. So area is still going to be length times width. That doesn't change. Problem is my number is going to get quite big. Let's see what it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we're looking at 24 times 10. Okay. We've talked a little bit about a little shortcut that we have when our number ends in a 0. I'm not even going to focus on that though. I want to really work through what could we do here. And boys and girls, in one of our last units when we were still in the book, what would it have been? Maybe lesson 4 or lesson 5. We talked about breaking big things like this into smaller parts. Okay. But the thing is, we also talked about that with Mrs. Kling too, where we talked about how if we've got, let's see, 8 times 6, and we can't remember 8 times 6, we could think about 4 times 6 and 4 times 6 and just add up those two answers and we would get the same as the 8, right? We talked about how that 8 could be broken into 4s, right? Well, if that 8 could be broken into 2 4s, what could that 10 be broken into? If this is my shape, and this is my 24, and this is my 10, could I break that 10 into 2 5s? Sure, I could. It's exactly the same thing as this. And this is what that lesson was showing us the last time we were working on the book. I think it was one of the last 2 times. Okay. The problem with this is that I'm not sure that I could figure out 24 times 5 any easier than I could figure out 24 times 10. So maybe we don't want to do that break. Maybe, what's our other option? How could we break this guy up? Well, let's see. How could we break up a 24? That would be easy for us. Could we say that 24 is equal to 8 plus 8 plus 8? Well, let's see. What is 8 3 times? Is 8 times 3 24? Well, let's see. 8 plus 8 is 16, plus another 8 is 24. So what if I did this? Now you saw I didn't measure it. I'm just kind of showing you an example. So instead of 24, now I'm thinking 8, 8, 8. So area would be 8 times 10 plus another 8 times 10. Whoops. Oopsie. Plus another 8 times 10. Because we'd be saying 8, 1, 2, 3, 4, 5, 6, 7, 8, 10 times. 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. So I would just take this. Let's see, you know what 8 times 10 is. So this area would be 80. This area would be 80. This area would be 80. So now all you have to do is add those up. 8 tens. Remember what 8 3 times is? Not 8 tens, I'm sorry. 8 3 times was 24, but these aren't ones, these are tens. So it wouldn't be 24, it would be 240. Because 80 plus 80 would be 160. And you know, since I'm a make tenner, what I'm doing is I'm saying 160, and I'm actually in my head adding 10, because I'm a make tenner, and I'm taking away the 2. So if I have 160 plus another 100, that would be 260, but I added in too much. I didn't want to add 100, I only wanted 80, so I'm going to take away that 20, is 240. So the area of the ballroom, which is right here, is 240 square, I just do SQ, units. Okay, so I'm actually really pleased with how that combined our previous lesson and what Mrs. Kling had already taught us, so I want to do another one. And I want to start back with what Mrs. Kling taught us. Let's say the problem, the multiplication problem, is 9 times 6. And you're just a little iffy with 9 times 6. Of course, one thing you could do is you could change this to 9 times 5. 9 5 times. You could count by 5s. And then just add in one more 9 because it's 6 times instead of 5 times. That could work. Or you could think about 6 10 times. And then just take away a group of 6. 6 groups 10 times. Or 6 in 10 groups. Take away one group. Okay. But what you could also do is think, well, wait a minute. I do know that 6 could be broken into a 3 and a 3, right? I do know 9 times 3. So 9, I could say 9 times 3 plus 9 times, 3. And I happen to know that 9 times 3 equals 27. So in my head, I'm just thinking 27 plus 27. 20 plus 20 is 40. 7 plus 7 is 14. Let's do that. So I've got 54. If I had done 6 times 10, so here's my thought bubble. If I had done 6 times 10, I would have said that the answer was 60, right? So that would be 6 groups, or 6 in a group, 10 groups, right? So if it's only 9 groups, I would then have to take a group of 6 away. 54. Okay. So the point is, you can break this up. Okay. I chose to break this one up because it was an even number and it would break evenly. If there's something that makes you comfortable about breaking that one up, go ahead. Okay, we already knew that lesson. Okay. Mrs. Kling had already gone over that with us a couple times. And I always like to connect what we're learning to something you already knew. So that's why I'm starting with this. But boys and girls, let's look at this in a shape, okay? Let's look at this as 9, 6. So there's going to be 6 rows, and there's going to be 9 columns, okay? You know, think of it this way. This one's a little bit too big, maybe something like that, okay? Doing this and breaking that 6 into 3s would be exactly like doing something like this. So now instead of thinking of 9 times 6, I can think of 9 times 3, 9 times 3. So if the area of this guy is 27 and the area of this guy is 27, all I have to do is add those two together because the two together make the 1, right? My area would equal 54. That doesn't look like a 5, does it? Okay. So let's look at the Queen's Chambers. Now that we've reviewed that, let's look at the Queen's Chambers. Okay. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Is this the same size as the ballroom? 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost the same size. Oops. Almost the same size as the ballroom. Since that's so close to the ballroom, let's look at the throne room. Now remember, does your throne room have to be this big? No. And to be honest with you, I might have made the throne room 1 bigger. Why not make it bigger, right? And not waste that space, but who cares? Okay, let's look at the throne room. Since the Queen's Chambers were so close to the ballroom and we already did that one, let's look at the throne room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So when you look at this at first, and you remember you're thinking area equals length times width. So the whole way of figuring out the area, this goes up here. The whole way of figuring out this area is to do this multiplication, but you're going, Mrs. Mandeville, how in the world am I going to do that? Okay. What 2 things could we multiply instead of the 17? Yes, it would be much easier to break up the 8. But boys and girls, if I broke that 8 up into 2 4s, is 4 times 17 going to be any easier for you to do? Probably not, because 8 isn't the problem. 17 is the problem. So I'm thinking we might want to break up that 17. And I'll be honest with you, because I'm a make tenner, my first thought was to do a 10 and a 7. So what that would mean is 10 times 8 plus 7 times 8. And let's look at that on here. Okay, so this was 8. I wish I had a pencil. Let's see. So this was 8, and this was 17, right? What we've said here, if we choose to do the 10 and the 7, is that we're going to break this 17. Hang on 1 second. Gotta get my cap on before I get this all over my bed. Sorry. Okay. So what we're saying here is that instead of figuring out this whole thing, we're going to break this guy. Okay? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now instead of thinking about 8 times 17, now I'm going to think of 8 times 7 and 8 times 10. So if I do it that way, 8 times 7 is 56. You might not have known that one immediately, but I know you know this one. 8 times 10 equals 80, right? Now I've got to figure out 80 plus 56. And yes, that's tricky, but all you need is a piece of scrap paper. You know how to do that. So here's my scrap paper. Ooh, there's a fancy 8. 80 plus 56. Okay, well, let's do the tens. 80 plus 50 is 130 plus 6 equals 136. So what that would mean if I was checking it is that there would be 136 squares in here. Let's see.